So I'm going to start here within our vendor services view. What we've done, I mentioned that web page integrity kind of started from a kind of a more broad scope where we were really looking at protecting any type of sensitive data in the page, and surely we do that today still. But what we've done for PCI is developed a PCI DSS module that is both a technical and commercial offering where you can get just what you need for these requirements, just for the payment pages. And that's what I'm going to go through today. So anything that I mentioned is part of that technical commercial offering. Of course, if you have other concerns about, hey, we take passport numbers, we take, IDs or other sensitive pieces of information, logins, account numbers, we can certainly look at protecting that. But today, since we're all here for PCI DSS, will stick to that scope. So the first part is this vendor services view. And this view is largely mapped to requirement 643, though there is some overlap. And where we start with that is the inventory. So what we do to make the inventory a little simpler to manage, as I alluded to, is we group scripts into what we call vendor services. And as the name implies, it's typically made up of a vendor and then the service that they're providing to you in the page. I've got Google Tag Manager here as an example. Any script that's associated with this vendor service will show inside of its inventory. We'll take a look for Tag Manager here. Will be listed under the scripts view. Here I've just got one, but if it were made up of multiples, you'd see those here. And in the case of tag managers, especially if they're loading other scripts, right, from other vendor services, your marketing teams or what have you are using these to load other vendor services, they will get their own entry. As you'll see out here is, there's some others for Stripe, New Relic, PayPal, all receiving their own entry within this vendor services view. The next part of 643 is that authorizing. And I've got two examples here today of a vendor service that we're going to authorize, one being Stripe and one full story. So how convenient, you mentioned Stripe earlier, Jeff, where we'll go through and do the authorization and understand why we might authorize or might decide to restrict a particular vendor service, how we'll help with that process. So to get into Stripe, taking a look at them, you'll see they're showing in this needs review status, which is how we'll highlight any vendor service that should be reviewed for the purposes of compliance. You'll see I've got everybody else sitting in this authorized green button status. So let's go through Stripe. When I click on the view details button, I will be given a history among a couple other panes, and we'll see that Stripe is here because they've just been detected on the page. So they have no previous authorization. So web page integrity saying, hey, do you want to give them an authorization? Well, we can decide if we want to authorize Stripe by examining their behavior. You'll remember I mentioned, hey, when we see a vendor service, when we see a piece of script, we want to understand something about it before we make that decision. Here in the behaviors view, we can see exactly what Stripe wants to do in the page. Well, in this case, they want to transfer data back to stripe.com. They want to add an iframe to the page in some instances. And then this page also sometimes collects the payment data in a form that's directly in the page. So we also have where they're collecting data from that form. Now, Stripe is a card processor. So of course they need access to the card data and they need to transmit it in order to process it. And since they're doing all of that with their own domain, looks pretty safe, and we'll go ahead and decide to authorize them.
Well, and if I can interject,
sure.
It's important, I think, to point out that the 643 requirement does spend a fair amount of time saying, in this example, you, the merchant, are not responsible for any scripts that are running on what Stripe, once the iframe presents whatever Stripe is presenting.
In the frame.
They've got their own scripts and they're PCI compliant. So they've got their own QSA reviewing what they're doing to keep track of all. And hopefully they're a customer of yours too. But that's on them. It's all the scripts that you're discovering that are before you get to the Stripe
before
part
the frame, right?
Is what the merchant needs to worry about and is concerned about. And that's why they need you. I'll let you go continue.
Yeah. And that's what we're seeing. Like I said, that's what we're detecting here is what's outside of the frame, right? So an important note to make, and the original reason that everybody moved to frames for processing cards is that script outside of the frame can't reach inside, and vice versa. There's some caveats there, but for today, I think that's enough. scripts inside the frame also can't reach outside of the frame directly, and so that creates, one of those sandboxes that Jeff was talking about, restricts the scope of those scripts and doesn't allow them to access data directly. So what we're seeing here is the script that Stripe is putting into, in this case, the merchant's payment page to generate that iframe. And so when we go through and authorize them, we want to make sure that they can do networking, right? This observed networking that they have shown. We want to make sure that they can add the iframe to the page. And then in situations where we don't, we also want to make sure they can grab that data from the form. Now, what this is going to do when I hit save is it's going to create on the back end what we call a behavior contract. And what this says is, okay, I understand that Stripe, this vendor service, and by extension, the collection of scripts, are going to exhibit certain behaviors in a page in a normal circumstance. As long as those scripts stick to those normal behaviors, we'll still examine the scripts to make sure that they're safe, check and make sure they don't contain any known bad script or otherwise, but we won't ask you to reauthorize the Stripe vendor service. We've already accepted a level of risk from Stripe and said, hey, it's okay if they add frames to the page, this particular frame, it's okay if they communicate with this domain, and as long as any scripts that come after that or are modified, changed, followed by that behavior contract, we won't ask for that reauthorization. So even though we're doing some checks in the background to make sure that those scripts are safe, I'm not going to ask you to come back in and look at the exact same information to approve that script. The opposite of that is what we'll see here with full story. And if we look at their details, we'll see that not too long ago, a coworker of mine, a John F., came through here and provided some initial authorizations for full story, but now we've got some changes to, in fact, the same 3 behaviors that Stripe was asking for. So let's take a look at those. When we take a look, we'll have some blue dots here that are showing us, highlighting to us the new behaviors or modifications to a behavior in this case. And if you'll pardon my blatant naming scheme here, I've got a domain that we perhaps don't trust so much, a new full story domain, and then in this case, another domain that they don't necessarily own. We've also got them now wanting to add an iframe to the page, which is a little suspicious, and then also have them accessing the form data where previously they were only grabbing an email. Now they're grabbing all the card information as well. So little suspicious. So what can we do? When the agent-based model of web page integrity, when we go to authorize, we can in fact authorize full story to be back in the page, but we're going to be able to restrict it. We can say, hey, we want to block some features of the script, and in this case, let's choose to block all. We'll block all the networking, the form data access, and the iframe actions to prevent them from potentially leaking any payment information off the page. And when we do that, we will, of course, move full story back to authorized. First, we'll go to this ready to apply status that will ask us to rebuild the agent. We will include all of the rules, all the behaviors that the agent should perform when it encounters full story into that agent code, and then redeploy it out to our CDN. And the very next person that goes through a checkout will get this updated version of the agent. And just to show, how that looks for the end client, I'll go through a quick checkout session here. We'll kind of skip through the shopping section and the address, go straight to the payment form. So what we'll see while we're here is even though the agent is in the page, and even though it's preventing certain behaviors by full story, it doesn't cause the page to slow down, have poor performance, or otherwise break the experience or the transaction for the end client. So it's still easy for them to go through, make a normal transaction just like they would expect, get a confirmation page, and move on, right? So for them, the process is completely transparent, even though we're taking extra actions in the page that will get detailed about back over here on the dashboard in the live feed. And in the live feed, we'll see a number of different alerts that are coming in that are confirming for us that we've blocked some behavior, some of that being where full story is trying to add a frame to the page. And for many of you out there that are in, say, SAQA type merchants or others that are framing in their payments, this is what we would expect to see if there's a web scam attack against your page in particular. we'll be able to collect the information about anything from the headers of that frame, if they're defined, and also be able to tell you exactly which script and then what document in this case is causing this behavior. And even if it's a script triggered by a script on down, we'll give you that stack trace to make it easy to go back and find out who's generating this iframe. This is really important, and like Jeff, you mentioned earlier, a lot of these skims are starting to target frames. Another one that would be good reading if you take a look, and hopefully is in that article you reference, one that we've seen recently is what we call silent skimming, where the attacker, rather than trying to copy the frame manually, instead they will examine the payment processor when they make a request to load the frame. That Stripe script we looked at earlier, they will do the same request. The attacker will, and then use a copy of that frame, put it back on their server, serve it from their own domain, and it will look exactly like the payment processor script or iframe, because it is, right? It's a perfect copy of it. They'll show it in front of the malicious script, or sorry, the malicious frame will be in front of the legitimate frame. They'll ask the cardholder, in this case the victim, to enter information in that frame, and once the transaction has gone through the malicious one, they will say, oh, hey, sorry, there was an error, would you please try again, and then move the legitimate frame to the front. That way it's very hard for both the cardholder and for the merchant to detect that there is some type of skimming going on, because legitimate transactions still occur, and to the cardholder it just looks like a small error. But here we can pick out those exact behaviors and help you to either mitigate them, which we've done here with the agent, or to come up with a way to remove that from the page and keep the cardholder and the business safe.
Well, it's funny because in the early days of the internet, this whole notion and idea was something that was done with various different communications protocols back then, but things that we used to call session hijacking or man in the middle of attacks, these are really just sort of evolutions of those concepts. So sort of old ideas, just new application.
Right.
Good job. Good job, bad guys.